Good morning, students. Today we are going to learn crystal systems. The unit cell may be characterized by relative lengths of the edges along the three axes and the angles between the edges. There are 32 different combination of elements of symmetry of a crystal. These are called 32-point groups. However, some of system have same axial angles and ratios. Thus, some of system have been grouped together into only 7 different categories known as 7 basic crystal system. These are cubic, orthorhombic, tetragonal, monoclinic, triclinic, hexagonal, and rhombohedral or trigonal. Now, all these systems are written in this table, so we are now going to discuss this table. So, first system is cubic system. In cubic system, your all axial lengths, that is length along x-axis, y-axis and z-axis are same. So that's why it is written as A is equal to B is equal to C. All the angle between the planes are 90 degree, that is alpha, beta, gamma is equal to 90. So in this cube we clear cut see that if we are going to calculate angle between these three axes, so it is the angle between all three planes, it is always equal to 90. That's why alpha, beta, gamma equal to 90. Now there are 9 plane of symmetry and 13 axis of symmetry present in your cubic structure. So example of this type of systems we see in NaCl, KCl, cesium chloride, Ag, Cu2O and zinc sulfide molecule. Now I am going to show you what is the meaning of 9 plane of symmetry. So previously we discussed that plane of symmetry means a imaginary plane which can cut your crystal into 2 equal half. So there are 9 such a plane present in your cubic structure. Now how that 9 planes? So just see here. If we place a plane from this point and this point, if a plane comes from here and cut it like in this fashion from here to here, we got 2 equal half. Now if another this is the first plane which is coming like this way, there is other plane which is gone like this way, there is third plane which can cut this geometry from here to here, there is another plane also which cut this geometry into 2 equal half which is come from here to here. So there are total 4 plane now. This is your fifth plane which cut this geometry into 2 equal half. If I pass a plane like this, it also cut this geometry into 2 equal half. So it is your sixth plane. If I cut this geometry like this, so this plane is also cut this geometry into your 2 equal half. So it is your seventh plane. If I cut this geometry like this, it also divide this into 2 equal half. So this is your 8th plane, and if I pass a plane from here, it divides this geometry exact 2 in 2 equal half, so it is your 9th plane. So in a trigonal or rhombohedral crystal system, all axis length are equal, but just see that your alpha angle is always equal to beta, beta is always equal to gamma, but they are not equal to 90. There are 7 plane of symmetry present in your trigonal cubic trigonals lattice, 7 axes of symmetry. Example of a molecule in which rhombohedral or trigonal cubic structure, trigonal crystal structure is found. It is Al2O3, Fe2O3, calcite, etc. Tetrahedral system. In tetrahedral system, A is equal to B, which is not equal to C. Alpha, beta, gamma always equal to 90. There are 5 plane of symmetry and 5 axes of symmetry. Example in which tetrahedral lattice system is found is TiO2, SnO2, Sn, urea, MnO4. Monoclinic crystal system. In this, A is not equal to B, B is not equal to C. Alpha and gamma equal to 90, but beta is not equal to 90. This monoclinic system have one plane of symmetry, one axis of symmetry. Examples is sodium sulfide, tin hydrate, or copper sulfide pentahydrate. Next system is triclinic crystal system, in which A is not equal to B, B is not equal to C. Alpha is not equal to beta, beta is not equal to gamma, and gamma is also not equal to 90. There is no plane of symmetry and axis of symmetry present in triclinic system. It is important. It is asked for 1 mark question in exam. The example of triclinic crystal system is copper sulfate pentahydrate, and example of monoclinic system is calcium sulfate pentahydrate. It is not copper sulfate. And K2Cr2O7. Hexagonal crystal system. In hexagonal crystal system, A is equal to B, B is not equal to C. Alpha beta is always equal to 90, gamma is always equal to 120. There are 7 plane of symmetry in hexagonal system and 7 axes of symmetry. Example is CDS, HGS, CD, zinc oxide molecule. In an orthorhombic system, A is not equal to B, B is not equal to C. All interfacial angle are equal, that is equal to 90 degree. There is 3 plane of symmetry and 3 axis of symmetry. Example is barium sulfate, potassium nitrate, sulfur, that is rhombic sulfur, etc. Now we are going to see Bravis lattices. The French crystallographer Auguste Bravis in 1848 observed that the atoms, molecules or ions occupied different places on the unit cell. Some of them may occupy the center of the body, while some of them are present at the center of each face of the unit cell, along with those at the corner of the unit cell. Thus, depending upon the position of atoms, molecules or ions occupied in the unit cell. Cubic systems are classified into simple cubic unit system, body center cubic unit cell, face centered cubic unit cell. So we are first going to discuss what is the meaning of simple cubic unit cell. In the simple unit cell, the atoms or ions are occupying only at the corner of your unit cell. Thus 8 points are located at the 8 corner of the cube. So just see here. This is the diagram of simple cubic unit cell. So in this diagram, we see that these points, which are basically atoms or ions, is occupied at the corner, at the 8 corner of your cubic structure. Now we are going to see body centered cubic cell, that is BCC. Body center unit cell has one particle at the center of the cube in addition to the particles at the corner. Thus, there are 9 points, 8 points at the corner and 1 point at the center of the cube. So, just see the diagram of body center cubic unit cell. So, in this we clear cut see that this particle, it is present inside of cube, while 8 particle present at the corner of the cube. Now what is face center cubic cell? FCC. FCC has one particle at the center of each face. It is important, one particle at the center of each face of the cube and one particle at each corner. Thus there are 14 points, that is 8 points at the corner and 6 points at the center of each face of the cube. Now just understand, this is your cube. This cube have 8 corner, 1, 2, 3, 4, 5, 6, 7, 8. It has 6 faces, 1, 2, 3, 4, 5 and downward face, that is 6. Now in FCC, at your 8 corner there is one particle is present. At the same time, at every face, so cube have 6 face. So at every face there is one particle is present at the center of the face. So this is the face of cube. So one particle is present here, one is here, one is here, one is here, one is here and one is from your downward plate at the center. So there can only be a 4. Thus, there can be only 14 different ways for the arrangement of these points in a 3-dimensional space. These are called as Bravis lattices. The Bravis space associated with crystal system are simply shown in following diagram. So just see, this is your cubic system. And cubic system is further divided into 3 types, that is simple cube, BCC cube, FCC cube. So in a simple system there are 8 particles present at every corner. In BCC there is 1 particle present at the center of your cube and 8 particles present at the 8 corner. In FCC 8 particles present on your 8 corner and 6 particle is present at 6 faces. This is the rhombo-orthorhombic space lattice, which are further divided into 4 types, that is simple. In simple orthorhombic space lattice, 8 points are present, 8 particles are present at the corner of orthorhombic space lattice. In BCC, 1 particle is present at the center, 8 present at the 8 corner of rhombohedral space lattice. In end centered, it is important, at end centered orthorhombic space lattice, there are total 8 particles present at the corner of your orthorhombic space lattice. Beside that, there are 2 particles present on opposite face, left and right. In FCC, 8 particles present on 8 corner, and on each face there is presence of 1 particle. So these are the diagram for tetragonal and monoclinic space lattice, and these are the diagram for your triclinic, hexagonal and rhombohedral or trigonal space lattice. So in our next class we are going to discuss coordination number. Thank you very much.